Hi, in this presentation we will study production systems. Production system will have three main components: the production rules, the working memory, and the recognized act cycle. The production rules, which are here with the mouse is moving, are gonna be expressions that are gonna have left hand side and right hand side. So the left hand side, what we see this C1 in this case is a condition, and in the right hand side we see an action. So then when there is a condition that matches on the working memory, we're supposed to execute that action. So going back here, so we're going to have a set of, we said that the production system has three main components. So one of them is a set of production rules. So the production rules will look something like this, okay? And each one of them by itself is called a production rule or just a rule. And then there will be some working memory that will contain the description of the current state, and um, that conditions may be matches one of the left hand side of the rules, and then in that case we will select, and that's the part that is the component, the third component that we recognize here, which productions will match that conditions that are in the working memory. Now we're not going to execute all the rules that are matched because it may be more than one rule that matches. Then we're going to have some type of conflict resolution system that will decide which one of the rules is the one that we're going to start. So by default, usually we say that the first rule is the one that is executed. So here again, so we have a working memory that is going to be checking for conditions. So then, and then we're going to be looking into this, and this is going to continue until there is no, I mean, when there is no more conditions found that execute any actions, that's when we end. Okay, so then this is the algorithm that we will use, that I want you to study just in the way that we're going to be checking for the matches or the pattern search in the rules. So I think we're going to have now everything clear with this example here. So here, this is my production system, system. Okay, so here in this example, we're gonna have 6 iterations. So this is when we start, and this is when we end. So we halt here, so that's when we finish. So initially in working memory, this is what we have. Let's see this like a kind of like a string. I mean, this there is something that has a meaning. So this is CBACA. So now what we do is we're gonna check if there is a match with the conditions that are in the left hand side. So we can go, and then again, we need to have a procedure how this is going to be implemented. So one way is that we can go from rules in order that we had that stored in the system. So let's go from 1, 2, and 3 and see if they are there. So here, is there a BA in the string? I see a BA. Then we add into the conflict set 1. The conflict set is the rules that will be matched by whatever information we have in the working memory that matches the condition. So BA is there, so 1 is there. Now CA, we see a CA there, so we're adding 2, and CB is there, 2. So now here there are 3 rules, all 3 rules are matched by the what we have in the working memory. Now we're only gonna execute one, we're only gonna fire one rule. So now we need to decide how is that we will make the selection. So for this example, what we're gonna do is the first rule. So like we're searching from, in this case, from left to right, and then the first rule is 1. So that means this is the one that is being executed. And for this example, what we're doing is this string BA is gonna be substituted by the string AB. So then here there was a BA, you see there where my mouse is moving. So now this is going to be substituted by AB. So now this is the new working memory. So again, this is just an example now. The challenge when we're actually solving a problem is to decide what is that we're going to have for the production system, how is that we're going to do the implementation. I mean, this is a very nice algorithm. Okay, so now again we do the same and see which one of the rules are here. And remember, when there is nothing else, that's when we halt. And in this case, this would be the way that it's going to be executing. So now, let's say is BA here. There is no BA. AB is not the same as BA. Then CA, it is there. So we're adding 2 in the conflict set. And then the CB is not there. Now, which one we're going to execute with the first one, and which actually the only one. So we execute 2, and 2 says replace CA by an AC. So the CA is replaced, rule 2, the now notice that the CA appears twice in the string, right? So again, when we're executing the rule, this has been executed once. So we were following that is whatever we find first. So the first CA is going to be replaced by AC. And then we continue with this process. Again, now we're going to check is BA here, is not, CA is here. So we got 2, and then CB is also part of the string. So these are the 2 rows. Now I need to decide which one is the one that is going to be executed. So we're going to execute 2. It 2 executed again was changing the first CA that we find by the AC. So now the CA is replaced by AC. And then we continue with the process until eventually we go here in 6, and there is no matches. Okay, so then for example is BA here, there is no BA, there is no CA, there is no CB, the conflict set is empty, then we halt. Okay, so here is an example of how we can implement this with a game. So let's say that we have the puzzle game and we want to use the production system to program an artificial intelligence application to play the game. So here, this is the state that says, okay, I mean, this is a possible state. Let's say that we start the game like this, and the goal is that we get into this state. Now, the actions, the possible options that are here is moving the blank, which in this case to the left. So that means left. In this case, that means the 7 is going this way, and then or up. So that makes sense. So we either go up, down, left, or right. That's what we can do. That's what we actually move all the tiles, and then we get into here. So now here, look at how we're modeling the system into production system. So here that's the rule. So it says goal is stay in working memory, and then if that's the case, we halt, and then if not, this is the rule. I mean, again, it's on us to make the definition of these rules. If the blank is not in the left edge, then there will be, like for example, in this case, it's not on the left, then we're gonna move um, to the left. So this will be the action. Okay. So here is the description of the conditions, and this will be the action, and we will do the implementation of this. Let's see on the next one. So here it shows let's say a sequence of how this can be implemented. So this is the start state. You see that here there are 3 possibilities. Now if let's say that we start using this production system. So for example, let's say that this is my current state. So I just start. So this is what is in my working memory. My working memory I only have this. Now I go and see if this matches one of these roles. So is this the goal? No, they are different. So it's not the goal. So this is not going to be in my conflict set, right? So now is the blank not on the left? Yes. So this rule is going to be there, and then it's not on the top. Yeah, this rule also this rule is there. It's not on the right, it is in the bottom. So the only conditions that are not in my conflict set is the first and the last. So that means I got three possible rules, moving left, up, and right. And that's what we have here. So from here I got 1, 2, and 3. Now, once I have these, again, you had to design some type of um, conflict resolution rules, right? And we can combine this with, once we have this graph, maybe with what we have done with the greedy algorithms with A star, or I mean we can do a combination, or because for example here we can say, well, from here we go over here, this is the first one, and then we continue. Now here again, if this is the current state, again, which rules are the one that match? You see that it's at the bottom and it's on the left, so it's not the goal, is blank is on the left, is not on top. So in that case, I mean, we just follow I mean, whatever is the rules that matches here, right? We continue with the graph. But I mean, this is a nice example how we do the representation.